All right, you should have picked up three things on your way in. If you're remote, in the folder for this week, in Unit 9, the week of 426 to 430, at the very bottom, there's three things. One says naming acids review notes. Another one, acid-based background reading. Another one says acid-based background reading. It says worksheet, but not really worksheet, more like a thing for you to organize your notes. Uh, so when it comes to concentrations and molarity, it could be ionic compounds like salt in water. It could be a covalent compound like sugar in water. But one of the most common things we deal with as concentrations are acids and bases. The only way you can realistically have an acid or have a base is if it's a solution in water. So we already went over how to name acids. We haven't done anything about bases yet. We will, because one common clue as to whether something's a base. You good? All right. Um, but this thing says naming acids review notes. This is a review of how to name acids. So I just want to go over this kind of briefly so that we're kind of all back on the same page. You remember how to name acids because there's three major kinds of acids that you need to know how to name. So the naming acid review notes, that's available for you to like see, and it's mostly the same kind of stuff as what we went over. We spent almost a whole week on naming acids. It was back in January. We were remote. It was like January 7th or something like that. I think that's right. Is that right? I don't even remember. I have no idea when we were remote. It's been a crazy year. And then this acids and base background reading, that's the like stapled together thing that you got if you're in class. But this has a overview of what acids are and what bases are in terms of them as solutions. And then you can measure the acidity of something or how basic it is either with a concentration or by measuring the amount of hydronium ion that's in the water, which is from the hydrogen that's in the acid itself. And we use a scale, the pH scale, which you may be somewhat familiar with, to describe how much acid is in a solution or how much base is in a solution. And that's actually a logarithmic scale. So I'm going to give you time to like, self-read that and collect your notes and organize your thoughts about that kind of stuff. So let's just go over real quick about like naming acids. Let's see, someone else is here. Okay. So the thing about all acids, you can identify most acid compounds because they will begin with an H. There are exceptions um, to that rule, but in general, when you see formulas that begin with an H, they are usually ionic compounds that have hydrogen as the cation, and then some other thing either as a monoatomic or a polyatomic ion as the anion. So the two major kinds are binary acids like HCl. So HCl on the periodic table, hydrogen has a charge of 1 plus, and then chlorine, because it's in group 1, has a charge of 1 minus. All right, it is 1 plus and 1 minus. So in order to put the compound hydrogen and chlorine together, hydrogen and chlorine, because they have a charge of 1 each, you only need one of each, and it's just HCl. And we have a rule for naming that compound. On the other hand, you could have a compound like this H2SO4, and in this case, hydrogen is still the cation, H1 plus, and sulfate, like I got the polyatomic ion chart on this screen now, sulfate is SO4 2 minus, and because sulfate has a charge of 2, and each hydrogen only has a charge of 1, in order to have a neutral compound, you got to have 2 hydrogens for every 1 sulfate, so the formula is H2SO4, because you need 2 of these hydrogens each with a charge of 1 to go with 1 of the sulfate with a charge of 2 minus to end up with a neutral compound. So binary acids, binary means two names or just two elements, hydrogen and chlorine. But these oxo acids oftentimes have oxygen. You'll see that for all the ions on the polyatomic ion chart, all of them all have oxygen in them with two exceptions. The ammonium cation is at the very top, and then the cyanide anion is on there as well. But all the rest of them, oh, and thiocyanate, yeah, but all the rest, they have oxygens in them. That's why we call them oxoacids. They're polyatomic ions that commonly have oxygen atoms in them. I mean, the two major components of water, well, the two atoms that make up water are hydrogen and oxygen. So it stands to reason, is not surprising that acid solutions oftentimes have hydrogen and or oxygen atoms, making them up anyway. So the way you name acids, you always find the name of the anion and you ignore the fact that there's H. So in other words, in that example, HCl, the name of the acid has nothing to do with the fact that hydrogen is the cation, but the name of the acid comes entirely from the name of the anion, the chlorine. And the number of hydrogens don't matter either. So for instance, hydrochloric acid is named based upon the name of the uh, acid name for the chloride anion. If it's sulfuric acid, like H2SO4, it doesn't matter that there are two hydrogens. The name of the acid comes from only what the formula for the anion is. You don't ever write like dihydrogen or bihydrogen or something like that. So again, the names of acids only just come from the name of the cation. So with binary acids, it's hydrogen and one other element. It's always aqueous and dissolved in water. So here's a thing to know. I probably mentioned this back in the day when we did acids, and HCl is an excellent example. There is HCl as a gas. Hydrogen will bond with chlorine atoms to form a gas. And when it's a gas, that's called hydrogen chloride because it's named the same way that you would name any other ionic compound. What hydrochloric acid is actually hydrogen chloride gas dissolved in water. So when we write acids, all acids have an AQ after it whenever they're in solution, and then the name changes to hydrochloric acid. It's very much like if you have carbon dioxide and you put it into water, it makes an acid called carbonic acid. So if you have soda water or you've got carbon dioxide dissolved in water, like in a bottle of a Coke or something, that the carbon dioxide is dissolved in the water, you can say there's carbon dioxide dissolved in water, but more importantly is to say you've now got a solution of carbonic acid, that the carbon dioxide dissolved in the water formed carbonic acid. And then it's not really CO2 AQ because the carbon dioxide actually reacts with the water to make this acid called carbonic acid, which has a different formula than carbon dioxide does. But that's a little different exception. All right, so for example, HBr and HF, just as a review, HBr, that's hydrogen and bromine for uh, uh, acids just made of two individual compounds, regular binary acids. The name of the anion here, well, the name of the element is bromine, but as an ion, it's the bromide anion. And all binary acids, the name is always like hydro and then something ic acid. The something that goes in here is the root of the name of the element that is both the root of the element name and the anion name. And for bromine, it's this brome. So HBr is hydro, and you put a brome in there, hydrobromic acid. Same thing with HF. F is fluorine as an element. The element name is fluorine. The ion name is fluoride. The root in fluorine and fluoride is both fluor, so the name of HF is hydrofluoric acid. So that's just a quick review of names of acids for binary acids. For oxo acids, there's the polyatomic ion name for the oxo acid. And sometimes you have to change the root, and we add acid to the end of the name. So if the acid ends with 8, we change the name to ic. So for instance, if it's I don't know, find a good one. Well, it doesn't really matter. Like here, nitrate. So the nitrate anion is NO3 minus. So I have hydrogen and then NO3. The NO3 it is the formula for nitrate, and nitrate changes to ic. So instead of hydrogen nitrate or something like that, the nitrate, the 8 changes to ic, and the name of the HNO3 then, HNO3, is nitric acid. So going down, acetate changes to acetic acid, bromate is bromic acid, carbonate is carbonic acid, chlorate, chloric acid, but that's not really a thing too much. Chromate, chromic acid, and so on and so forth down the list. So the name of the acid ends with just acid. There's no hydro at the beginning. So for instance, H2SO4, the reason why the hydrogen has a charge of 2, I kind of already did this one, is that hydrogen has a charge of 1, and then SO4 is sulfate. So down here is sulfate, and the name of this was sulfate. You just change the 8 to ic and add acid at the end. The sulfur is one exception to the rule about changing the name. Sulfate comes from the element sulfur, and the name of this acid is not sulfic acid, but sulfuric acid. The reason why that's an exception is a lot of elements end with the suffix "ium" or "ene," but sulfur ends with an So when we change sulfur to we change sulfur to sulfate. It'd be weird to call it sulfurate. So we don't call this ion sulfurate, we just call it sulfate. But the whole root is all the sulfur. So sulfuric acid is a bit of an exception. I guess I already just kind of did nitric for nitrate, but this NO3 is the nitrate. So it was nitric acid. H3PO4, when you look on here for PO4, that's the phosphate. This was from the phosphate anion. 8 changes to ic, but phosphate's another exception. If you were to change 8 to ic, it would look like phosphoric acid, and that's kind of weird. Phosphorus, um, phosphorus ends with the same ending sound like us, kind of like So if the end of the name has a U in it, oftentimes you want the whole phosphorus element name, and it's phosphoric acid. So basically you're looking for the root of the name or the whole name if it ends with an or an and throw an ic at the end. So H3PO4 is phosphoric acid. So going down, like, I don't know which other ones. Uh, well, that's pretty much it. Those are the major ones that we've used in name. And they're very common acids. Hydrochloric, sulfuric, nitric, phosphoric, highly common acids. Acetic acid is also very common. We've used acetic acid, that's vinegar. The anion name is acetate. And whenever you get rid of the 8 and then end it with ic, it becomes acetic. And that's what vinegar is. So the flow chart that I showed you before that we used is, does the anion contain oxygen? If not, it's just a binary acid probably, and the name is hydro with the root ic. If it contains oxygen, then it's an oxo acid. If the end of the name is ite, the end of the acid changes to us, and if the name of the anion is ate, the end of the acid changes to ic. So the 3 common acid names end with hydro or have hydroic or end with us. or end with ic. And based upon the ends of the names of the acid, you can tell what the name of the anion had to be. So if the acid ends with ic, the anion ended with ate. If the end of the acid is us, the end of the anion was ite. If the name of the acid is hydroic, it was just from a binary acid just containing chlorine or bromine or fluorine or some other gas like that. All right. So that is nothing new about naming acids, but because we're going to work with solutions containing acids, it's very important to be able to identify acids based upon their names anyway. So that little review, that was this review, and you can keep that handy. The other thing you just got says acids and bases, and it has a brief overview about the plan for acids and bases. The first page, let's see. Yeah, so and if you're remote, this thing says acid and base background reading. And online, it's sorry about that. It's just a scan. Well, it's a scan of this. So of course it's also in color, but this just turned out to be a scan of it. That's just kind of where we ended up. So you know generically about acids and generically about bases, but acids and bases play a very, very important role in basic, that wasn't like a joke, basic chemistry, play a very important role in biological systems, a very important role in like ecology and earth science. And the paper that goes with that, so if you're remote, there's another page, this is acids and bases background reading worksheet. There are some different definitions for acids. So this acid and base background reading, that's the same link as the other one, but it's a PDF that you can download if you want to view it like in some other kind of way. So it just looks like this. So it's actually redundant. But the second thing says acids and base background